Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0107, indicates a low voltage condition in the manifold absolute pressure MAP sensor circuit of the Honda Civic model years 2011 to 2015. The MAP sensor plays a crucial role in measurement for engine management, providing data about the engine's intake manifold pressure, which the Engine Control Module, ECM, uses to optimize fuel injection and ignition timing. A malfunctioning MAP sensor can lead to a variety of performance issues, including poor engine performance and increased emissions. When the vehicle's onboard diagnostic system detects this abnormal low voltage, the ECM triggers the P0107 DTC, prompting the need for a thorough diagnostic procedure. Trustworthy troubleshooting and repairs are essential to maintain vehicle functionality and emission standards, particularly for Honda owners keen on a reliable driving experience. This presentation aims to guide through the diagnostics and solutions pertinent to the P0107 error. The MAP sensor's primary function is to measure the pressure in the intake manifold, which is critical for air-fuel mixture calculations in engine control. Located within the engine bay, the sensor is connected to the intake manifold through a port, allowing it to capture real-time pressure data. This data is relayed to the Engine Control Module, ECM, and aids in determining how much fuel to inject based on engine load and speed. If the MAP sensor circuit has low voltage, it may signal underperformance, resulting in delayed response in acceleration and torque, stalling, or check engine lights illuminating. Additionally, inaccurate pressure readings can lead to improper fuel delivery, resulting in increased emissions and lower fuel economy. Hence, understanding the role and location of the MAP sensor is vital for effective troubleshooting. Several possible causes might lead to the P0107 code being triggered. A faulty MAP sensor can directly result in incorrect voltage output, thus falling below the necessary thresholds. Another potential cause is open wiring, where a break in the circuit prevents proper voltage flow from reaching the sensor or ECM. This situation typically occurs due to physical damage or wear over time. Finally, shorted wiring can create a resistance imbalance that affects the signal being transmitted, which may also be responsible for the low voltage condition. Each of these issues can severely impact engine performance, making early diagnostics crucial for proper repairs. Therefore, each potential culprit must be thoroughly examined during the troubleshooting process. The symptoms associated with DTC P0107 can vary, but are generally indicative of a malfunction in the MAP sensor or its circuit. One of the most immediate indicators is the illumination of the check engine light on the dashboard. This serves as a warning to the driver that the vehicle's engine management system has detected an issue. Performance issues such as poor acceleration can occur as a result of incorrect air-fuel mixture ratios, leading to reduced power delivery. Additionally, rough idling might be experienced as fluctuating air pressure readings impact how the fuel is managed at lower RPMs. Other symptoms can include increased fuel consumption and potential stalling, all leading to a decreased overall driving experience. Recognizing these signs early can ensure timely diagnostics and repairs. To initiate the troubleshooting process for DTC P0107, begin by verifying the problem. Start by turning the ignition switch to the on position, ensuring that the vehicle's electrical systems are activated. Next, utilize the Honda Diagnostic System, HDS, to check the MAP sensor's data in the data list. If the data indicates that the MAP sensor reads approximately 3 kilopascal, 1.0 inches, or 26 millimeters Hg, or 0.23 volts or less. It confirms that the failure has indeed duplicated, necessitating movement to the subsequent step. Conversely, if the data checks out indicating no such readings, the system may be functional at that moment, suggesting possible intermittent failures or issues with connections at the map sensor or ECM. This step sets the baseline for further investigation into the potential causes of the low voltage condition in the map sensor circuit. Following the initial verification step, the next phase in troubleshooting DTC P0107 requires disconnecting the map sensor for further testing. Begin by turning the ignition switch to the lock position, allowing systems to power down completely. Proceed to disconnect the map sensor by unplugging its 3P connector. With the sensor disconnected, turn the ignition switch back to the on position to power the systems once more. Again, check the map sensor's data using the HDS to see if it still indicates a low voltage condition about 3 kPa or 0.23 volts or less. If the same low voltage data points are observed, you're now prompted to move to step 5, focusing on replacing the map sensor. If results differ, further inspection will be required to address other potential issues in the circuit. In this crucial step, we now measure the voltage to identify faults present within the map sensor circuit. With the ignition switch still in the on position and the map sensor 3P connector disconnected, measure the voltage across specific test points, VCC1 and SG1. The first test point is designated as the map sensor 3P connector number 1, gray wire, while the second is at map sensor 3P connector number 3, pink wire. The measurement should indicate approximately 5.0 volts for everything to be functioning correctly. If you observe this voltage reading, it indicates that the map sensor itself is defective, necessitating its replacement before moving forward to the repair verification stage. Conversely, if the voltage reading is absent or significantly lower, it requires proceeding to the next step to check for circuit continuity issues. To further delve into potential wiring issues, this troubleshooting step focuses on checking for open circuits in the VCC1 wire. Begin by turning the ignition switch back to lock, which powers down all systems. Next, use the HDS to jump the SCS line, a procedure that allows access to onboard diagnostics effectively. After jumping, disconnect the necessary connectors, specifically the SG1 gray, VCC1 pink, and the map sensor 3P connector. With the connector unplugged, check for continuity between two test points, the ECM connector C49P number 23, pink wire, and the map sensor 3P connector number 3, pink wire. Should continuity exist, this indicates that the VCC1 wiring is intact. In such a case, you should check if the ECM contains the latest software updates, or consider substituting with a known good ECM followed by repair verification. Lack of continuity indicates an open wire that must be repaired between the ECM and map sensor. After addressing open wire concerns, the next step is to verify for potential short circuits in the map sensor wiring. Start by ensuring the ignition switch is turned to the lock position, ensuring safety and system shutdown. Jump the SCS line using the HDS once again for proper access. Following this, disconnect the ECM connector B, 49P. Next, check for continuity between the map sensor 3P connector number 2, green wire, and a body ground with the map sensor still disconnected. For a proper functioning circuit, continuity should be confirmed. If found, it implies that there is a short along the map PB line, requiring appropriate repairs to be conducted. If continuity does not exist, It signifies the MAP PB wiring is acceptable. In such a case, you would update the ECM software or substitute it with a confirmed operational unit, subsequently following that up with repair verification. After completing the necessary repairs for DTC P0107, proper verification is crucial to ensure everything is functioning as intended. First, ensure all related connectors are securely reconnected, including the MAP sensor and ECM connectors. Next, turn the ignition switch to the on position and reset the engine control module, ECM, using the HDS. Following the reset, perform an ECM idle learn procedure. This assists the ECM in recalibrating its parameters after servicing. Lastly, check for any pending or confirmed DTCs using the HDS once more. If DTC P0107 is still indicated, it suggests that either the issue persists or there are poor connections to address. If the ECM was updated during this stage, a known good ECM substitution may be necessary to ensure the problem has been properly resolved. If no such codes appear, troubleshooting is deemed complete. To mitigate potential future occurrences of DTC P0107, implementing a preventive maintenance schedule can prove beneficial. Regular inspections of the MAP sensor for physical damage or corrosion can encourage early detection of problems, allowing timely action. Additionally, checking the overall condition of wiring connected to the MAP sensor and the ECM helps identify any signs of wear, loosening, or abrasions, which could lead to open or short circuits. Ensuring the ECM software is updated to its latest version is critical, as automotive technology continually evolves for optimal performance and efficiency. Lastly, familiarizing oneself with typical symptoms, such as the check engine light or performance issues, allows drivers to act promptly, thereby protecting their vehicle's functionality and longevity effectively. In conclusion, understanding DTC P0107 and its implications on the Honda Civic from 2011 to 2015 underscores the importance of maintaining efficient vehicle operation. The diagnostics process involves systematic troubleshooting to verify where in the circuit the issue lies, whether it be faulty wiring, sensor malfunction, or ECM complications. Following through with the verification process after repairs guarantees that the solutions implemented have resolved the issue effectively. Additionally, integrating preventive measures can greatly enhance vehicle reliability and performance. Overall, tackling DTC P0107 with a comprehensive and informed approach promotes a better driving experience while helping to meet emission and performance standards set forth by manufacturers. Please like and subscribe to the channel. See you next time.